How do I find an equation for a line in 3 dimensions? On the right, I have a graph with the 3 axes, x, y, and z, and the line L in which I want to find the equation for it. The green vector r0 is the vector from the origin to the point p0, which is a point on the line that is represented as x0, y0, and z0. And the vector r is an arbitrary point p that's represented as x, y, z. And finally, the vector v is parallel to the line L that's represented with the components a, b, c. Now, how do I take these 3 vectors r0, r, and v and create an equation relating all of them together? Now, if we isolate these 3 vectors, I have a diagram of r0, and this is r, and this is v. Now, by vector addition, we know that the sum of 2 vectors is a diagonal of the parallelogram formed when we connect the 2 vectors together. And we can see that if we multiply v by some constant t, we can form the parallelogram and have r as the sum of r0 and v, or t times v really. And we can represent this equation as r equals r0 plus t times v. And now if we plug in the values for each of r, r0, and v, we can use x, y, z for r, x0, y0, z0 for r0, and a, b, c for v. Then if we add the components together, we can get this equation. Then we separate the x, the y, and the z components to have what is called the parametric form for a line in 3 dimensions. And in conclusion, we can see that all we need for an equation for a line in 3 dimensions is one point on the line as well as one vector parallel to the line. Now let's do an example. Find the equation for a line containing the points a, 2, -3, 1, and b, -2, 4, 3. As we've established before, we need one point on the line as well as one vector parallel to the line. Now from the givens of our question, we see that we have actually 2 points on the line, so all we need is to just pick one, but we need to find the vector parallel to the line. And for this question's sake, I'm just going to use a as the point on our line, but we still need to find the vector parallel to the line. So hypothetically, if I'm given a line and I also am given 2 points on the line, we can see that a vector parallel to the line is actually the line containing the 2 points themselves. So this is the vector. And if this is A and this is B, then this vector is vector AB. So this is all we need to find for the vector parallel to the line. And vector AB is just represented as the B components minus the A components, which is -2 minus 2, 4 minus -3, 3 minus 1, which turns out to be -4, 7, 2. And now we have a vector parallel to the line. We've also established that the equation for a line in 3 dimensions in parametric form is x equals x0 plus a times t, y equals y0 plus b times t, and z equals z0 plus c times t. And our x0, y0, and z0 values are the components of a, and the a, b, and c values are the components of ab, which we have here. So all we need to do is to just plug in the points and we have our equation. So we have x equals x naught, which is 2, plus a, which is negative 4, times t. Y equals negative 3 plus 7t. Z equals 1 plus 2t. And this is our final equation.